Welcome to Chapter 8.4b lesson video. Today we're going to talk about how to stretch these sine and cosine graphs. Let's go ahead and dive on in. So today we're talking about the horizontal and vertical stretch. In other words, we're changing the amplitudes and periods of our sine and cosine graphs, what that looks like, how to do it, and where to locate it as part of the equation. So first, let's talk about changing the amplitude. If we want to change the amplitude of a sine and cosine graph, what we're going to do is we're going to add an amplitude modifier in front of the sine or cosine graph. Basically, we're being multiplied. If you want to toss a little multiplication symbol in there, that is fine. That totally helps. But the main thing to remember is our a value can't be 0 because if you multiply by 0, it'll become 0. What this will do, though, is it'll change the height of the graph. So if you multiply by a 2, the amplitude will now be a 2. If you multiply by a 5, the amplitude will now be a 5. The thing is it changes the height of the graph by an absolute value. So if you multiply by a 7, it'll now have a height of 7 above the middle line. But if you multiply by a -7, what happens is that it flips the graph and it has a height of 7. So now what it means by flips the graph is rather than a sine graph going up and then coming down, it would go down and then come up. So it just kind of does the opposite movement. It flips it around a little bit. So let's go ahead and talk about that. So first thing we're going to do is we're going to label our x-axis. So we're just going to fill in those pieces. So if that's 0 and 2 pi, that means this is pi. This is pi over 2, and this is 3 pi over 2. That's pretty standard at this point. Same thing over here. We'll go ahead and do them both while we're at it. Pi over 2, 3 pi over 2. Then what we're going to do is we're going to label our amplitude. So the first thing we're going to do is we're going to notate our amplitude. So our amplitude here is 2 because there's a 2 in front. Our period is still 2 pi. Nothing has changed in this problem. The other one over here, we will say our amplitude is 3, not -3. We'll say it's 3. Our period is 2 pi. And we're going to make a little note to ourselves that it flips. And we know it flips because that's a -3 in front, not a +3. We'll label our y-axis as well. So since the amplitude is 2, we'll go up 1, 2, or down -1, -2. And then we'll plot our points. Our sine graph looks the same as before. We don't have to worry about making a table or anything like that. We know what the shape is now. So it starts out at the middle line. It goes up to the maximum amplitude, back to the middle line, minimum amplitude, middle line. So it's just the same graph. It really looks the same for all purposes. The only way we know it's different is because our y-axis is labeled to show us that the amplitude is now 2 rather than 1. This graph over here, it's -3 cosine x. So our cosine graph would normally start up 1. But what we're going to do is we're going to start down 3. So we're going to start way down here at 3 because we're going an amplitude of 3. And the reason we're starting down rather than up is because of that negative value right there. So we'll go plot our first point down there. Oh, I'm having a little bit of issues. Let me go ahead and slide my picture up a little bit so I can plot the point actually. Down at -3, then our middle line, then +3, then our middle line, then -3 again. I actually forgot to label my y-axis. So let's go 1, 2, 3, -1, -2, -3. Now this is just our cosine graph, but it's flipped because of that -3, and then it's an amplitude of 3, so a height of 3. So it goes up way higher and down way lower than it normally would. So there we go. That's how we change our amplitude. Not too crazy, not too complicated. We just have to look at this a value in front. That tells us how high or how low to make the wave. And then if it's negative, we flip the direction that it starts out in. So this cosine graph, rather than starting up, is now starting down. And it does the same motion, just in a opposite manner. The period change is a little bit more complicated. Let's go ahead and talk about it. So for our period change, what we're going to do is we're going to look at the number in front of the x inside the trig function. So this is the sine of bx. It's inside the trig function, inside the parentheses here, in front of the x. Now, here's the deal. That b value is not our period, so it's not like amplitude, but it's what we call our period modifier. So we'll have the same shape, we'll have the normal sine and cosine graph, but what happens is the normal period, which is normally 2 pi, is going to be divided by whatever that b value is. So our period is normally 2 pi, but we're dividing by that b value. Now that requires us to do a little bit of math. It's nothing too crazy, but it does help us find our new period. Once you find the new period, you have to label your x-axis with that. Let's go ahead and see what that's going to look like. So the first one here, our amplitude is still 1. Our period is going to be 2 pi divided by that period modifier of 2. 2 pi divided by 2 is just pi. So what that means is that our fourth mark over now, instead of being 2 pi, is pi. We find the other marks doing the same thing as before. We cut it in half. Half of pi is pi over 2. Half of pi over 2 is pi over 4. All right, so we cut it in half again. Well, if each dash mark is a pi over 4, the third one over will be 3 pi's of 4. The amplitude we said was 1, so we're going to go up 1 and down 1. Now here's the tricky thing about this is it looks exactly the same as our original sine graph. The only way I know that anything's changed on my sine graph here, go ahead and add the points as well. The only way I know anything's changed is because I can look at the x-axis and see that those labels have changed. If you don't change these labels right here, I'll never see it and I'll never be able to tell and I'll never be able to give you those points. Our second example, pretty similar, different period though. So our amplitude is 1. Our period is going to be 2 pi divided by 1/2. When we divide by a half, we multiply reciprocal, so we get a 4 pi for our period. So that means our fourth mark is 4 pi. Half of 4 pi is 2 pi. Half of 2 pi is pi. 1 pi, 2 pi, this is 3 pi. Our amplitude, we said, was 1. So 1 and -1. And then this is just a normal cosine graph. So we start up, middle line, down, middle line, up. The only way we can tell anything is different is because of those labels. So when you do these graphs, every time you do them, you got to label your graphs appropriately. If you're not labeling your graphs, I'm never going to be able to give you full credit on these assignments. All right, we got one last thing to go over. When you're doing these problems, I like to think about it as breaking it down into these few steps. The first thing you're going to do is look at any simplification in the equation. We haven't really had any of that yet, but we will. I'm going to find the period by taking 2 pi and dividing by my b value, 2 pi, and dividing by the b value by that number inside of the trig function. I'm going to find my amplitude. That's just whatever the a value is. If it's not there, then it's 1. I'm going to label my x-axis. Now remember, you label your x-axis. This is where you do the cut in halves thing. So we're going to say 2 pi, cut in half is pi, cut in half is pi over 2. And then the third one over is just 3 times that, 3 pi over 2. Then you're going to label your y-axis. That's just whatever your amplitude is. So you're going to go up or down, however many your amplitude is. And then you're going to draw your points and plot. And the shape is pretty consistent. So you don't really have to worry about the shape. You don't have to make a table or anything. It's going to stay pretty consistent throughout all these problems. With that, you should have enough information to be able to get started. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. Until then, I hope you have a great day.